Okay. Hi friends. In this particular video, I am giving you brief idea about timing diagrams of 8086 in maximum mode. Okay. So in the last video, I explained the operation of 8086 in maximum mode. Okay. And last before video, I explained the timing diagram of 8086 in minimum mode. So with that knowledge, we can easily draw the timing diagram for maximum mode here. Okay. Let us see how to draw the timing diagram for maximum mode of 8086 operation. So now I am sharing maximum mode operation of 8086. So we observed that in the last video what is the operation of 8086 in maximum mode. So here there is a one external okay, I will highlight it. Right. Now this is external bus controller. Name is 8288. Okay. Now this is act like a one slave, and microprocessor 8086 microprocessor will give you command to 8288 via 3 pins here: S0 bar, S1 bar, and S2 bar. With the help of these 3 pins, 8086 will give you command to 8288, which operation it will perform. Okay, accordingly it will activate trans receivers as well as latches and as well as any of the control signals, right? And one more is the clock range, clock frequency range of 8288 and 8086. They are synchronized. Here the clock frequency, see here, clock frequency this one, and similarly clock frequency of 8086. Both are synchronized with the same value. Okay, then with the same rate 8288 perform the operation. Okay, as based on the command given by the processor. Okay, so here also we are taking multiplexer address and data lines and make it like a pure address lines and pure data lines with the help of ALE signal coming from the 8288 and DT by R bar signal, DN signal. Okay, with the help of these 3 signals we are activating latches and trans receivers. Accordingly we will get. Okay, anyway, in the last video I given complete overview of this. Now here now confined to today's topic, that is a timing diagram of 8086 in maximum mode. For that here in 8086 timing diagram, especially in maximum mode, we get first ALE signal. This is essential. ALE signal will be appeared, then multiplexer address and data lines, then multiplexer address and status lines, and VHG bar slash S7 required. Okay, then clock is essential. Without clock won't perform any operations. Then all see memory read, similarly memory write or advanced memory write. These 3 are required, depends on the problem. Then similarly IO read, IO write, or advanced IO write. So first 6 we are using in timing diagram. In addition to multiplex lines, then clock, then similarly DEN, DT by R bar, and ALE. Okay, all these signals are essential for developing the timing diagram. Let us see first part. Now, for example, 8086 wants to perform a read operation. Okay, let us see how to write the or how to develop the timing diagram. So in that also, let us see first part same here also clock. What is the role of clock? Clock simply generates clock pulses with a range of 1 bus cycle or 1 clock cycle. So here from T1 to T4 simply I am calling as a 1 machine cycle or bus cycle. So first here status lines are required. It depends on the problem. For example, where we need to activate status lines S0 bar to S2 bar. Okay, so here in generally, okay, this is also optional, not required. Depending on the problem, we can analyze it, but it's not important. For status lines activation is not essential. So, but let us see first one. Clock is essential. T1 is the first part of the machine cycle. T2 to T4 are the remaining parts of the machine cycle. Okay, first address and status lines. Okay, then BHG bar slash S7. Here multiplex address and status lines. BHG bar slash S7 are transmitted to are considered are the multiplexer lines, and during T1 time they are processing, and after T1 what happens, they act like a pure status lines and pure address lines and VHG bar, like that they are separating after T1. Okay, next similarly address and data lines also AD0 to AD15 if you take. So these lines also processed during T1 time. Actually during T1 time they act like a address lines, and remaining time they act like a data lines. So like that we have data lines from T2 to T4 time here. Okay, so now data lines are available from T2 to T4 time. Okay, before T1 they act like a multiplex lines. During T1 they are processed and make it like a pure address lines. Okay, after getting pure address lines, remaining time T2 to T4 they act like a pure data lines. Like the data lines are available. Then what is the next one? ALE. This is important. ALE should be high during first part of the machine cycle. This is first part. During T1 time, this is T1 time. T1 time ALE must be high. The remaining part of the machine cycle it should be low. Okay, and this ALE is used along with latches to separate these multiplex lines into pure address lines as well as status lines. Okay, and data lines accordingly. Now, but let's see what is our aim. We should perform read operation. For that, we can select either memory read or IO read. For example, the processor wants to perform memory read operation. Then MRDC memory read command is MRDC. See here, this MRDC must be low. Is actually in our case memory read command bar, IO read command bar, like that they are bar signals. Remember, they are bar signals. Okay, in order to activate, what happens? These two must be low during T2 to T4 times. Here during T2 to T4 time these lines must be low. Then only it will perform either memory read or IO read. Okay, then what is the other one? DT by R bar. It's a tri-state pin. Tri-state means it is not 0, not 1 before T1. Okay, now DT by R bar, if for read operation DT by R bar should be 0. For write operation DT by R bar should be 1. So DT by R bar should be 0 for receiving operation, nothing but read. 1 means for write operation. And before T2 actually, before T2 it should be tri-state, means we are not giving 1 and not giving 0. Why? T2 to T4 time only we have data lines. Okay, like 8086 minimum mode also I mentioned same way. Okay, then other is in 8086 minimum mode we have DN bar signal, DN bar, whereas here DN only. This is important, DN only. So when DN is activating by giving 1. So where we are giving 1? During T2 to T4. See here, during T2 to T4 time DN should be high. Then only DN signal is activated. Okay, so like that which are important. So ALE should be high during first part of the machine cycle and low remaining part of the machine cycle. 1 point. Second, multiplex address data lines are act like a multiplex lines before T1. During T1 time they act like a address, and after T1 they act like a data lines. Like that lines are available. And multiplex address and status lines and BH bar / S7. These lines also before T1 they act like a multiplex lines. During T1 they are separating it into address lines and BHE bar, address lines and BHE bar. After T1 they act like a pure status lines. Okay. Then for read operation, especially memory read bar command must be low during T2 to T4 for memory read operation. For IO read operation, IO read command bar, IORC bar should be low from T2 to T4, whereas memory read command bar should be low from T2 to T4 for memory operation. For IO operation, any one should be performed. Okay, as per the requirement. DT bar should be low for read operation and high for write operation during T2 to T4, and should be tri-state for the remaining time. Okay, and DN must be high during T2 to T4, and DN should be DN only here in 8288, whereas in 8086 in minimum mode it is DN bar that should be low, whereas here it should be high. That's the difference. Similarly for write wave, so we have clock is essential and clock should be from T1 to T4. So this is optional for this. So coming to address lines, here also multiplex address and status and BH bar / S7. Then address and data lines. All three are 21 multiplex lines are there. So before T1 they act like a multiplex. During T1 they are separating like a address and BH bar for this case, and after T1 act like a status. Similarly AD0 AD15 also before T1 they are like a multiplexed. During T1 they are separating like a address. After T1 they act like a data lines, D0 to D15, means T2 to T4 we have data, T2 to T4 time we have data. Next ALE should be high during T1 time, and from T2 to T4 the ALE should be low. Separate lines. Then for write operation, see our aim is write. So for write operation what happens, we can select, we have two writes, memory write, okay, similarly advanced memory write command. Okay, so normally, okay, see advanced memory write command, advanced IO write command, two write commands are there. We can use advanced or normal. Normal, see memory write command bar, MWDC bar means memory write command bar, IO write command bar, other one is IO write command bar. Advanced memory write command bar or advanced IO write command bar. We can use any one. For example, write operation what happens, all are bar signals. These signals must be low from T2 to T4 10. Okay, for either we can select either memory or IO. So if it is memory, it should be low from T2 to T4. If it is IO, that should be low from T2 to T4. Here also DN should be high from T2 to T4 time, and before T2 it should be low. Okay. Then if you make it this type of timing diagrams, we get a write operation of 8086 in maximum mode. Okay. So like that we can analyze read operation as well as write operation related to memory or IO easily. Okay. So right. So thank you for watching this video. I hope you understand how to develop timing diagrams for both maximum mode in memory mapped IO as well as IO mapped IO. Okay, both read and write operations. Okay, thank you for watching this video. Okay, if you really like, please kindly share my video to your friends and subscribe my channel. So do you have any suggestions or any queries or any requirement, please kindly make it comment in comment section. Accordingly I will act. Okay, accordingly I will help you wherever it requires. Okay, thank you so much.